Lesson 1-2, the rational numbers on a number line. So in this lesson, we're going to look at numbers on a number line, how you can identify where the positive and the negative numbers are located. We're also going to identify the additive inverses, and we're also going to simplify rational numbers in absolute value problems. So first off, some vocabulary. The additive inverse means adding the opposite of a given number. You'll know it means the opposite because there's going to be a negative involved with it, or if you think of the subtraction just means opposite. So it's also the additive inverse. If you don't see the words additive inverse, it might be referred to as opposites. So they're the same digit but with different signs. So an opposite of a positive would be a negative, and vice versa. The opposite of a negative would then be positive. So a number and its additive inverse, if you add them together, it would give you a sum of 0. And the last part is the absolute value. The definition of absolute value is just the distance from 0. So if you're finding the absolute value of a number, the distance is always going to be a positive number. So if you look in the diagram here, if they said x equals a positive a, I would put a positive a in for x. The absolute value of a would be a. And then if I put a negative a in for x, I would do the absolute value of negative a. The absolute value of negative a would be a positive a. So if I put a number to this, let's just say this is a positive 4 and this is a negative 4, really we're asking you how far away is 4 from 0 and how far away is negative 4 from 0. They're both equal distance away from 0. They're both 4 steps away. So that's what they mean by absolute value. Now let's look at on a number line. When you look at a number line, the number line here, you have the center number would be 0, because 0 is neither positive nor negative. But that's the dividing part between your positive and your negative numbers. Your positive numbers are always going to be to the right of 0. So those are your bigger numbers. Your negative numbers are going to be to the left of 0 because those are your smaller numbers. Now, this is just one example of a number line. If you think about a thermometer is a vertical, but you still have the same types of numbers. You're going to have 0, which is neutral. It's neither positive nor negative. But the numbers above 0 are positive, and the numbers below 0 are negative. So let's look at some problems here. It says simplify the following. Here they're saying n plus a negative 3 1/5 equals 0. So if we think the additive inverse, so if I take a number and add the inverse, the additive inverse of it, or the opposite, it's going to give me 0. So the opposite of a negative 3 1/5, n would have to be a positive 3 1/5. Next one, we have the absolute value of negative 1.5 minus the absolute value of 0.5. So how far away is negative 1.5 from 0? That is 1.5 steps away. And then I have minus, how far away is 0.5 from 0? That is 0.5 steps away. So now I can subtract my two answers. 1.5 minus 0.5 is 1. Next, I have to simplify the problem inside the absolute value first. So 4.5 plus 1.2 is 5.7. Now I can take the absolute value of 5.7, which is 5.7. 5.7 times this negative, there's actually a negative 1 on the outside. So negative 1 times 5.7 is a negative 5.7. So that is the only way you're going to have a negative with your finding the solution to an absolute value, if there's a negative on the outside. Next, we're going to be multiplying two integers here. So a negative 20. So a negative 20 means what's the opposite of a negative 20? Well, that's a positive 20. So anytime you see two negatives in a row, just think it's a positive 20 times. So this dot means times Negative negative 24 means a positive 24. So 20 times 24. So if I did 24 times 2, that's 48. And then 20 times 24 would give you 480. Next, absolute value of 60 is 60 divided by the absolute value of negative 15 is a positive 15. 60 divided by 15 would give us positive 4. Next, we have a multiplication inside the absolute value, so we do the multiplication first. So 6 times 5 is 30. So this is negative times the absolute value of 30. Absolute value of 30 is 30 times the negative 1 makes it a negative 30. Example B, find the additive inverse and the absolute value of each rational number. So all we're going to do is just find the opposite and then what is the absolute value of the number. So the opposite of a negative 4.25 is 4.25. And then the absolute value of a positive 4.25, or the absolute value of negative 4.25 is 4.25. Next, the opposite of 6 4/5 is a negative 6 4/5. And the absolute value of 6 4/5 is 6 4/5. So again, our absolute value is always going to be a positive number. The opposite of a negative 7/13 is a positive 7/13. The absolute value of negative 7/13 would be a positive 7/13. And our last one, the opposite of 9/10 is a negative 9/10. And the absolute value of 9/10 is 9/10. And practice problem C's. Here we're just going to be simplifying these. So we got 37.3 plus a negative 37.3. They are the additive inverses of each other, so that would be 0. Here we have 17 plus 35, which will give us 52, but there's a negative involved with here, so we have an absolute value of a negative 52, and the absolute value of negative 52 is 52. Next, 12 times 12 is 144. So I have a negative on the outside, 144 on the inside. The absolute value of 144 is 144. 144 times a negative is a negative 144. And our last one, the absolute value of negative 189 is 189. Divided by the absolute value of 9 is 9. And then we do 189 divided by 9. Well, I know 9 goes into 18 2 times, and 9 goes into 9 1 time, so it would be 21. So that is our lesson on rational numbers on a number line.